Hey y'all, it's me, Miss B. We are continuing on with modeling algebraic expressions. So to model a situation with an algebraic expression, you're going to do the following. First, you're going to identify the actions that suggest operations. Those operations are addition, subtraction, multiplication, and division. Then you're going to define one or more variables to represent the unknowns. So that means you are going to have to name them, which a lot of people forget to do that, so don't forget. Next, represent the actions using the variable and the operation. So basically all this means is write the expression or equation. Let's jump right into these examples. So you start with $20 and save $6 each week. What algebraic expression models the total amount you save? So each week is going to tell us that we could have any amount of weeks. So let's call our week W. But I'm saving $6 each week. So I'm going to do 6 times W because I'm going to have my number of weeks and then I'm going to multiply it by 6. And I also start with $20, so I'm adding 20 to whatever I make each week. So that right there is my algebraic expression. Next up, try it on your own. You had $150, but you're spending $2 each day. Spending means subtraction. So I'm going to have $150 minus $2 each day. I have to define D as day. You have to define. Otherwise, you're going to get yourself into trouble. So make sure you define those. And that is the expression that we wanted. Oh no, I erased it. I meant to highlight it. And there's our expression. Next, to evaluate the expression, you're just substituting a number for each variable in the expression, then simplifying using PEMDAS. In other words, evaluate means plug it in. You should remember that from yesterday. Now, sometimes it'll give you these really nice directions. What's the value of the expression for the given values of the variables? Or sometimes it might just say evaluate and give you nothing else. So you need to make sure you know what that word means. So we're plugging stuff in. Let's see. So A is A is -4. We're plugging that in for A. And B is 5, and we're plugging that in for B. So 7 times A plus 4 plus 3B minus 8. If you remember, I always put those parentheses in there so I don't get confused. A is -4, B is 5. And then we simplify. So, using PEMDAS. So, parentheses first. Remember that these parentheses right here, that's just fancy multiplication. It's not actually parentheses. These, however, over here are parentheses. So, -4 plus 4 is 0, and we're done with our parentheses. Next, exponents don't have any. Next, multiplication. I have 2 multiplication. I have 7 times 0, and I have 3 times 5, which is 15. Finally, addition and subtraction from left to right. So I have addition right here, 0 plus 15 is 15, and 15 minus 8 is 7. So 7 is my final answer. This next problem here is a little bit more complicated, but still doable. So I'm plugging in 1 for x and negative 1/2 for, positive 1/2 for y. So x is 1, y is 1/2. So you can plug that into your calculator and you'll get 1/2 plus 1/4, which is 3/4. Next, we have a word problem. It says, in football, a touchdown, T, is worth 6 points, an extra point kick, K, is worth 1 point, and a field goal, F, is worth 3 points. Write an algebraic expression that models the total number of points that a football team scores in a game, assuming each scoring play is one of the 3 given types. So go ahead and write that equation. It should be very similar to the problem we did up above right here. So go ahead and do that. What you should get is 6t plus 1k plus 3f is our total. It says, suppose a football team scores 3 touchdowns, 2 extra point kicks, and 3 field goals. How many points did the team score? Go ahead and do that one on your own. What you should do is you should plug in 3 for t, 2 for k, and 3 for f, and solve. So we get 18 plus 2 plus 9, which is 19. Alright, lastly, we're going to do some combining of like terms. I'm going to do the 2 problems on the left, then you can do the 2 problems on the right. So, looking at this equation, I can see that 7x squared and 4x squared have like terms because they have the same variable and they have the same exponents. Same thing with 3y squared and 2y squared. They have the same variable and the same exponents. So we can combine those terms. So 7 plus 4 is 11x squared. And 3y squared plus 2y squared is 5y squared. The variables do not change after we add them. Go ahead and do the next one on your own. You should see that the only like terms are j squared and j squared. And so k and j are going to stay the way that they are. Negative 4j squared plus 1j squared is negative 3j squared. And then we just rewrite these two. Next, we have negative 3k plus m plus 2 times the quantity k minus 4m. First, we want to distribute to get rid of any parentheses. So I get negative 3k minus m plus 2k minus 4m. Oh, wait, I forgot to distribute. 2 times 4 is 8, so I get minus 8m. And then I combine like terms. Negative 3k and 2k is just negative 1k. Negative m minus 8m is negative 9m. There's our answer. Go ahead and do the next one on your own. What you should get is distribute these, and you get negative 8a minus 3b plus 20a minus 50b. Combining like terms, you get 12a minus 53b. So there are your answers, and that is it for today's notes.